Here we are running into the underground crypto Moonbase research laboratory runs crypto. So if you didn't know, the title of the show today is called Who Runs Crypto? And that's what we're going to be talking about, right? This series has been moving us through a little bit longer. We're like a lot quicker, when the last series was literally a week of us talking about where value comes from, right? Now we're talking about who actually runs crypto. So at first glance, blockchain appears to be automatic. Transactions happen, blocks appear, state updates like memory, right? Or the ledger. The system seems to operate by itself. But underneath that software is a network of participants. Machines and operators working together to maintain agreement. And we talked a lot about how it's all one giant agreement. Even the value is very much agreed upon value. These participants run nodes. A node is simply a computer running the blockchain software. It stores the system's history and verifies that new transactions follow the rules. When a transaction spreads across the network, nodes independently check whether it is valid. And we've talked about things like ZK rollups versus optimistic rollups when it comes to validity or validating. They act as the system's guardians, right? And they also are what make up the system, because if you had no nodes, no validators, nothing would move and the system would really cease to operate or exist. Some participants take on more active roles, like validators, right? Validators collect transactions from the mem pool, where transactions sit and wait for the validator, and access them and assemble them, into blocks. So they go from the mem pool, they're put together in batches, those become blocks. These blocks are proposed the next state update for the network. So every time a block is minted on the network, you're really updating the ledger of transactions or the state of the network. Other nodes then verify that that block follows all the rules before they accept it. This coordination process is called consensus. And you'll hear us talk about like, oh, this is this blockchain's consensus protocol, aka how it works, the difference between proof of work, or proof of stake, proof of liquidity, proof of useful liquidity. There are a lot of variations and different takes across different networks about how to run consensus, but nevertheless, how it runs is the consensus of that network. Now, consensus allows thousands of independent machines to maintain a shared version of reality. If two conflicting histories appear, consensus rules determine which one of those the network accepts. The remarkable aspect is that no central authority decides. And so what is the whole point of this whole thing was to get away from a centralized, controlled system to a decentralized system. And somebody had to figure out, how do we make a system where everybody can participate and everybody kind of agrees and we have rules in place, but nobody's necessarily in charge. And we've done a whole series on who's actually in charge in crypto and who really has the power. Where is the power, come together in crypto, and how does power look in crypto versus in your traditional systems? Now, the network runs not because someone controls it, but because participants continuously enforce its rules. Oh, I missed this one. I skipped it. Instead, the system relies on incentives and rules. Participants contribute resources, computational power, and staked capital, and receive rewards for maintaining honest behavior. Crypto systems survive because agreement is maintained collectively rather than imposed centrally. Let's get our talking points ready for the next part. People are going to be paying a lot of attention to inflows and outflows for institutional ETF. All right, shout out to anybody who's here. Let's do those talking points. Let's raise that crypto IQ. It is the MO and the point of the channel. We have a lot of fun stuff to do, but we need to do our due diligence, and we're just getting to the end of that, right? So why blockchain needs participants? Why do we need people in blockchain? This should be a little bit self-explanatory, but remember, each show builds on itself and each week is its own series. Now, why blockchains need participants? Blockchains are distributed systems. They require independent participants to maintain records, validate transactions, and enforce protocol rules. Without participants, the system cannot function. Number two, what nodes do? A node is a computer running a blockchain software, right? Pretty simple. Nodes maintain copies of the blockchain protocol rules. Nodes enforce the system's integrity. Right there, I think, is probably one of the most simple ways you could tell somebody what a node is if they have at least a basic understanding of blockchain, right? So nodes enforce the system's integrity. A full node versus a light node, because you'll hear this terminology quite a bit. Full nodes store the complete chain history, all of it, and independently validate transactions, right? So you have the whole thing, all the memory, all the state of everything that has ever happened on a blockchain since day one, hour one, minute one, second one, whatever you want to call it. A light node relies on the full nodes for verification and requires fewer resources. Both contribute to the network's accessibility. Now, one thing that I've learned is that this is a bit of a challenge with most networks when it comes to scaling, right? Because it takes quite a bit of an ability, depending on the blockchain, depending on how old it is. Think about the difference between trying to store every transaction that's ever happened on SWI or Say, right? Versus trying to store every transaction that's ever happened on Bitcoin or Ethereum. It takes a lot more data, right? It takes a lot more memory and probably servers and actual physical gear to do that as a node operator or a validator or both. Where using something like a ZK proof, a zero knowledge proof, is actually going to be a huge advancement in this place of blockchain technology, because now you can verify without storing the entire history of every transaction. But somebody has to, right? Just because you can use a ZK proof to quickly verify something doesn't mean somebody doesn't need to hold the entire history. So let's put that into perspective. Hopefully I'm not getting too techie on you guys. Hopefully you guys are understanding what I'm saying. Bro, I'm going to make a short video on how to make a node on XRP and generate dollars by itself. Pretty cool, my man. Hey, I've checked out some of those. It's funny because a lot of the nodes run off of AWS. When I watched a video a long time ago about how to start and run your own XRP node, I wish I would have did it. When I broke the numbers down, I think it would have cost me about $220 a month, and that's paid to AWS to have their servers run that node. But yeah, make a video on it, man. That'd be really cool. I'd love to see it. I can post it on the channel if you want me to. If you want to just post it on your channel, that is up to you. I will let you make that decision for sure, because it's your decision either way. Full nodes store the complete blockchain history, right, and validate transactions. Light nodes rely on the full nodes for verification and require fewer resources. Both contribute to the network's accessibility. Validators and block production, right? So now we're getting into blocks, right? And it's actually being made in real time what is going on. Validators are specialized participants. So they are participants, but they're not just participants, right? Responsible for proposing and introducing new blocks. They gather transactions from the mempool and assemble them in the blocks, right? This is where it actually happens. Validators extend the chain, right? So they add the next block in the chain. Think of a link of chain, right? Somebody's got a long link of chain somewhere in their house they use for pulling another car out of a mud or something like that, right? Think of another chain link being added and another chain link being added and so on and so forth. That's what the validator is doing. Now, proof of work versus proof of stake. Sorry about that. So what we're talking about a lot here is very basic blockchain stuff. But when you get into different consensus, right, or different ways that take the word consensus and make it simple, right? The way a blockchain works, the reasoning and the rules behind how it works. For example, proof of work versus proof of stake. These are the two most common ones that people probably ever hear, but do you understand them? So if you've ever had anybody explain to you what Bitcoin mining is, then you were talking about proof of work. Proof of stake is different, but still is a consensus for networks. Ethereum moved from proof of work to proof of stake, where Bitcoin is still proof of work. So different networks choose validators differently, and this is where it comes down to. Proof of work uses computational effort to secure the network. An advanced mathematical, I want to say system, but that's not the right word, equation to constantly secure the network. Proof of stake uses locked capital as the security for the network. Both mechanisms determine who produces blocks. Consensus mechanisms. Consensus ensures that distributed participants agree on the current state of blockchain. And we talked a lot about agreement, right? We talked a lot about how when you go into a wallet and you have a transaction, that transaction that you see, that you approve and you sign it, right? Because I always say sign with your seed phrase or with your wallet, you're signing it, right? That you are a valid user in the network. That is just a proposal, right? When you click go, it doesn't just automatically become finality or finished on the blockchain. Then it goes to a mempool. Your proposal goes to a mempool. It's a suggestion, right? And it's not official until the validator picks it up out of the mempool, puts it in a block, and validates that block and makes that next link in the blockchain. I hope this is building day by day. So it prevents conflicting histories and double spending, right? Consensus creates a shared reality, an agreed upon reality. So decentralization and security. When many independent participants run nodes and validators, the network becomes harder to control or manipulate. Decentralization increases resilience. Incentives for participation. Now, we talked a lot about this with who runs crypto, value, like incentive in crypto is a very important point that you just can't go around, right? Participants are rewarded for contributing resources and enforcing the rules. Rewards align individual incentive with network security. And incentives can look anything like the fees that validators get for being a part of running the network to airdrops that is an incentive for people to participate in a test net, so the test net can be tested and eventually go live. Or mainnet, right? All right, so the core insight here is crypto networks function because independent participants collectively maintain and verify the system. So one thought that I really want to throw out there is that if Bitcoin wasn't mineable originally back in the day, if people couldn't earn money or earn Bitcoin by participating, and they still do to today, by the way, it just takes a lot more computational power and a lot more money. If there was no incentive, how much would the Bitcoin system have evolved? Like, right, would it have taken over in the way that it did? Would it have become such a big thing if you couldn't earn Bitcoin from doing that?